Thank you so much for coming. Today we'll continue pandas. So data assembly. So we'll talk about data assembly. All right. So I'm sure all of you have heard about TD data, where how we basically present or represent data or combine the data sets. So many times or most of the time you will have the data. Why you will have the data? Why you need to combine the data? Data is collected by humans, right? Usually by humans, by people, and then they will be added in different files. Maybe they will have the same column names, but different records, right? And you need to concatenate them, all right? Or maybe they have different surveys for the same people. So you will have like different columns. Okay, but same records, same indexes for the records, right? You know what I'm talking about, right? Okay, so for example, you could, for example, somebody will have like a survey, okay, is, for example, they, okay, A, B, C, whatever A, B, C, D, right? D, all right? And you have the record index 1, 2, 3, 4, 5, 1000, for example, right? And maybe other group collected the same thing, but for data, for example, F, G, H, whatever, and the same people, the same, indexes. You need to combine them together, right? All right, different files. It could happen also that you're having the same data, but for different people, okay, different records. So you need to merge them vertically. You need to merge them horizontally, right? So the source of the data could be different for many different reasons. So how we deal with such a data, right? So that's what we will talk about right now. So you have part of the data created for you. You have contact 1, contact 2, contact 3. All right. So. You can go here, all right? So can you see? Well, okay. So let's say that you have like 3 data, data files .csv, comma separated files. You have 3 separate files. So now when I have them in a file, what is the first step I have to do? Create data frame. So how we create data frame? Very simple. There is a function given to us which is read_csv, where it moves the data from the file to the data frame. So I have 3 files. I did it 3 times. I created data frame 1 in here. I did create data frame 2 and data frame 3. Very simple. Now I have 3 data frames. All right. So if I need to print them, how can I print them? Just print, right? Print data frame 1, print data frame 2 and 3. Let's run this one. Okay, see, you can see it, let's run it. Okay, here. Very good. So, in here, what you see in here, this is the data frame 1. Alright, how many columns it has? 4, A, B, C, D. And how many records it has? 4. Alright, we have data frame 2 also in here. How many records it has? 4. But notice, they are different or the same. Same, right? A, B, C, D, and different record. And then I have data frame 3, which is the same thing, which is A, B, C, D, and 4 records. So it seems like 4 people collected this data. Now we need to combine them together that you could do something with it. So how you combine them together? Very simple, very simple. There is a function given to you, okay, function is called concat. To concatenate. Remember, in here in pandas we're dealing with how many axes? 2, right? Axis 0 is the row, and axis 1 is the column. By default, if you don't specify for all these functions the axis, then this is axis 0. Axis 0, which is by row. All right. So in here, what I did, very simple. Okay, I'm creating a new data frame. I'm giving it, like, for example, a different name. Row_concat. What I'm getting it from concatenating the 3 data frames I have. What are the 3 data frames I have? I have to put them in the list. I have to pass them in the list. So list of data frames. So I have 3 data frames, list. So data frame 1, data frame 2, data frame, okay. And do I have to put this x is 0?
No.
I don't, because it's by default, it's the data frame, it's axis 0, right? All right, very good. So I'm moving down in here. Now I created a new data frame, and the name is row underscore concat. All right, let's print it. So I have it printed in here, printing concatenated rows. Okay. All right. And I really, by the way, I created this file by myself typing today, all right? It took me good like 4 hours, 5 hours, okay, to do the 3 chapters that I'm covering today. It took me myself, okay, like 4 hours. It takes some time, I understand. I really sympathize with you, okay, I know how much work you have to do and all of that, but that's the only way to learn, right? And I could send you the files also if you like, but I recommend that you try to do that, okay? Although you have them as like Juniper, you could use them, okay? But I like this more myself, okay? So whatever you like. So now, what we did, we created a new data frame. How many columns we have? 4. But how many records we have? 12. 4 plus 4 plus 4. You notice that it maintained the same. The same index. Remember from the first lecture how we reference the column by the name of the column, right? And how we reference the row by 2 things. By index value and index number. Label, which is and index number. Yeah. All right, so in here, as you see in here, there is duplicate of the indices, as you see in here. But in here, of course, it went very well. All right, so now let's play with it a little bit. All right, so if I need to iLock 3, what does this give me? So iLock is the index number 3. So how many rows is supposed to give me? So the first part tells me what? The row. The second part tells me the columns. I did not put anything in the columns. So I have to print all the columns. But how many rows I have to get? Row number 3. Alright? So if you look in here, so in here, the output in here, so it gave me, so what I'm picking in here, one row, it becomes what? A series. So when I print it, it will be printed as a series, right? We agreed on that last time. So sliding by index in here, and you see it in here, give me a series, right? Look at the trick in here and the problem in here. In here, when I say look or location 3, so in here I'm looking for what? The index label. Index label. So how many index labels with 3? 3. So in here, you're gonna print what? 3 lines for me. It will print 3 lines for me. You see in here? So it picked all the lines did. So very important to know how you are referencing or how you're slicing your data. Is it using iLock or lock? Big difference. Big difference in the answers. All right. Thank you for coming late. Good news, there's no project this semester. Yeah, don't believe me. We explained about the project, so and we did not record it, so you might need to talk to one of your colleagues or see me in my office if you need that. All right, so let's move on. All right, in here. So creating a new data frame. So here, what I did in here, okay, I create data frame. Remember, in the data frame, to create a data frame, how many square brackets I have to have? 2. If If I put only one, then what I'm creating? Series, right? Series. So I have to. So in here, what I did, I created a new data frame, and I called it a new raw data frame. All right. And I could always give a name for the column. So I said A, B, C, D, whatever. Right? It would go in here. A, D, C, D, right? Okay. A, D, C, D, right? If I print this one in here, this will be a data frame. Now, if I need to add my data frame to the first data frame, is that possible? Possible. So what should I use? The function concat. And I'm taking the first data frame, and taking my new created data frame, and when I run it, what I'll get? This is the new one I have created. This is the I have created. When I concat them, it was added nicely to the end. So I could, what's the point? What's the moral of the story here? I could concat existing data frames. I could create my own data frames. Then I could concat them or it with other data frames. The minimum I could concat how many? 2. Is there a limit for how many data frames I could concat? No. I could concat 3, 4, 5, 10, right? The ideal situation, what's the ideal situation? When it has the same shape. That means the number of columns, the same, and the name of the columns, the head of the columns are the same. Then they will stack them together, right? Together. That would be the ideal. That's the most ideal thing. All right. Sometimes, if you are collecting the same data from different people collecting the data, but for a reason they give it different titles, maybe you need to fix that first. Then when you concat them, it will be very nice. All right. But sometimes you need to concat data completely different. This is a major problem. It could give you a problem. It could give you empty locations. Clear so far? Okay, good. So in here, then moving on, in here, what I'm doing in here, okay, in here, in new concat by index, so you concat data frame 1, data frame 2, data frame 3, and what you are saying in here, ignore index, true, so that will reset the index, okay, for you. So you could reset the index. So take a look in here, Oh, so you have to make it false. If to reset, okay, printing, concatenating, okay, rows and resetting the index. So okay, so ignore the index, true, all right. If I change it, let's change it to false in here. And this one again. Did not change anything.
I just tried mine. It changed when the index was true.
What?
When the index was set true, it changed reset the...
Did it change it? Okay, not pay attention. So it's supposed to be here. True. It's wrong, yes. It did not reset. Did it reset the index?
Yeah, I just tried it.
I have no idea what's wrong in here.
I think that's because you're printing the row underscore concat.
Yeah.
Should be row concat.
Okay. Okay, which one?
Second row, yeah.
35 lines.
So you see the variable where you're printing row underscore
Line
concat, it should be
number 35.
undercode There should be underscore I at the end.
Oh yeah, row concat I.
Yeah.
You're printing the wrong one.
Oh, okay, that's fine. Thank you. So this has to be changed to underscore I. Now we're.
You might want to switch it back to false, I think.
No, it needs to stay
True,
true.
no, it should be true. Should be true. You see in here, it was reset. Alright? Alright? It was reset. So, good. Alright, then you have printing concatenating columns. So in here, now I'm trying to concatenate with column based. So I'm changing the axis to 1. Alright? So when you now what you are concatenating that by the columns. So you see A, B, C, D, A, B, C, D, A, B, C, D, and it was concatenated in the second axis, So it's a very important, if you need to concatenate in the column axis, that you have to specify the axis. Otherwise, by default, it should be 0. All right? And then in here, to do subsetting, how we subset to the column? By the column title. So if I need to, for example, print column concatenate for A, okay, it will be by, A, and gave me 3 columns. Why? Because I have 3 columns having an A. All right. By the way, I could also reset the column. If I say reset the column, to reset ignore the index, will reset in here. I think I did it in here. Okay, okay, not true. Okay. In here, I'm concatenating. You see what you did in here? In here, when I resetted ignored the index, it was resetted to 0, 1, 2, 3, 4. It removed the tab. Alright, so it's a very simple thing to deal with this, right? I agree? Everything's good? Alright, I wish life is as simple as this. Alright, it's not as simple and as easy as this. Alright. So in here we loaded the 3 files again to 3 data frames, data frame 1, 2, and 3. And we printed them again, just to display them for you. Data frame 1, data frame 2, data frame 3. Right? Now what I did, just for the playing with it, we changed the columns head, the column heads. So instead all of them were unified A, B, C, D. Now the first data frame has A, B, C, D. The second one has E, F, G, H. And the third one has A, C, F, H. Alright? So we're gonna do the same thing, see what difference. So what difference, okay. So in here after the changes, so you see after the changes, data frame 2, data frame 3, okay, we change the headings, right? So let's concatenate in the axis 0. So data frame 1, data frame 2, and data frame 3. The problem now that we have different columns. We have different columns. So when you try to do the concatenation, right, it will be messed up. Okay, I'm not sure why it's giving like that. Okay, in here, but as you see in here, A, B, C, D, E, F, G, H, these all the columns, and then it tried to paste the first 4 records from the first file, and the second 4 records from the second file. So it will be completely, completely messed up, because when they don't align, it will insert a value in A, N, in A, N means empty value. The NaN does not equal 0. It does not equal 0 in string. It's a value, and where is it coming from? From NumPy. Okay. By the way, I mean, you know, Panda is built in top of NumPy, right? So that's a problem. That's a problem. The problem is in here. Maybe it will be more clear in here if I put it in here. All right. So in here, when we try to go in here. So this is like index list by axis 1, y, print on A, and then run this. So in here we change the heads of the title. Yes, okay. Yeah, here what happens when you concatenate them, as you see in here. So it will take the first group in here, alright? The second group, because it does not have the same heading A, B, C, and D, created E, F, G, H, and put it in here. And the third one is mixed from the two groups. So whenever there is A, we put them in here, the C in here, the F in here, and H in here. So it created like a data frame which has lots of empty values, Alright? So that's a problem. What are you gonna do? I mean, let's say now, why we have to make the data frame neat before we start working? Because it will affect all the operations after that. So, for example, if I'm doing like addition, for example, if I'm adding this line, it will give you an AN, because if there is one value in AN, okay, it will not be able to do it, right? So I have to replace the AN, okay, or empty value, or I have to tell pandas, consider it 0, consider it whatever, okay, or change it to a different value. Alright, so we have to, before you do the analysis, you have to do all of that, right? So, you could ignore the index, the same thing, okay? And in here, for example, let's take this example in here. Now, so in here what you are doing, you're doing joining. So the joining, you took databases, right? So when you do joining database, there is inner, there is outer. Okay, outer include everything. Inner include the intersection, wherever there is intersection. Okay, left include everything in the left, and right include everything in the right. So there is 4, right? 4. So in here, when you in here, for example, data frame 1, data frame 3 join inner. Okay, so it will include the common ones between data frame 1 and data frame 3. What are the common ones between data 1 and data 3? Let's take a look. What are the common data 1 and data 3? So data 1 has A, B, C, D, and data frame has A, C, F, H. So what is the common ones? A and C only. So when it printed it printed A and C only. That's right. That's a common edge. Alright. So for the outer in here, the outer will print everything as you saw before. For the inner, it will see where they match, and where the columns match, and print all these columns. Okay, let's go to in here, okay, so if I do data frame 1 and data frame 2, so how many columns would it print? And if I do inner join,
No, nothing.
nothing. Why?
Nothing is involved. No
There is no
intersection.
intersection. There is A, B, C, D, then E, F, G, H. Okay. Okay. Any questions so far? So I think it's very easy, right? So we have learned about concat. There's a simpler one which is called append. You could append a data frame to data frame. Only one to one. Concat, you could concat many data frames. Many data frames. So we go back in here. So in here, alright, so this is data frame 1, data 2, 3, alright, so when I concat them with axis equals 0, we will join them together as we have seen before, alright, here I created my own, I created what? What I'm creating here? A series, not a data frame. So when I try to add it, alright, when I try to add this series in here, it was added in here and created all these empty spots. Created all of this empty spots, right? The solution is to create it as a data frame. You could use the append function, so you have, for example, data frame 1, data frame 1. Okay, if I need to append them together, you could append them with one command like this, and what is the command in here? So what I say, data frame 1, look in here, data frame 1 dot append, and then I could add the new row I have created. So I could append one row to a data frame, I could append a data frame to a data frame easily. Alright? I could also append the dictionary. As you see in here, this is a dictionary. So I could use the command, as you see here, okay, append, data frame 1, append, and then I passed the dictionary. Okay, so the dictionary was appended to the end in here. Was appended, okay? If I ignore the index, what will happen? It will reset the indices in here. It will reset the indices in here. Alright, so again, okay, if I need to add columns, column-wise, I have to change the axis to 1. As you see in here, this is the first one, okay, second one, the third data frame, they are added together. They are all added together. Alright? Alright, in here what I'm trying to do in here, I'm adding a series to the data frame. And we have learned how to do that from the first lecture. So column concat, I'm giving it a title or a head. It's not A, it's not B, it's not C. It's called a new underscore column list. Alright? And this is the value. So when I added it, it was added where? To here. So the head is a new column list, and these are the values added to add here. Alright? So basically what we're trying to say that when you have a data frame, you could concatenate multiple data frames in the axis 0 or in the axis 1. Alright? And you could add one series to the axis 0 or to the axis one, column wise or horizontal wise. And here what we did, we add the new column. How we create the new column? The name of the data frame, we give the head of that column, and then the values were added in here. Were added in here. Alright? In here, for example, you could add it as a series, not as a list. So you create a series. In here, in the previous one, we added as a list. So in here, what we have? A list, right? In here, we have a series, and again, it was added as a series to the end of the data. Okay? Alright, in here, we change the columns, heads, and we saw when we tried to concatenate them, created a mess. So in here, the first part, this is the first data frame, and the third frame is distributed in here and in here, right? So we learned about the join. The join that is outer, we'll add everything, and join equals inner. By the way, the default is outer, okay? If you need to use the inner, you have to specify the join equals inner, and this will join the columns, the intersected columns. The columns have the same title. So in here, we already saw that if we try to join data frame 1, 2, and 3 and inner, because there is no common intersection, so how many lines we're gonna have? 0. There is no intersection, nothing will be okay. However, if we do data frame 1 and 3 and we use inner join, how many columns we're gonna have? 2, because A and C are intersected. So that's what happens. Alright, we could do the same thing with the rows. So in here what we did, we changed the indices. So the first data frame, the indices be 0, 1, 2, 3. The second one, 4, 5, 6, 7. The third one is 0, 2, 5, 7. Alright? So that's the final look. So in here, 0, 1, 2, 3, 4, 5, 6, 7, and here 0, 2, 5, 7. So data frame 2 and 1, how many lines are intersecting? How many indices are intersecting? How many here intersecting with this?
Nothing.
Nothing. Okay, how about this one with this one? 2, 0 and 2, right? This one and this one? 2. Alright? So when we try to do concat in the column wise, again, you know, because you know the indices are not aligned, it created a lot of area, a lot of spots with empty spot, with the empty not available data. All right. So that's what you do when you do inner between data frame and data 3. We intersect only in 0 and 2, and print 0 and 2. Now in here to merge multiple data sets. All right. So you could merge 1 to 1, or many to 1, or many to many. Many to many. Merging multiple data sets. Fine. So in the first part, the data sets or the data frames is kind of similar, right? But what if they are completely different? So for example, let's go to take a look in here. So in here we're loading 4 different data sets. The first one is person. Okay, the second one site, survey, and visited. And take a look at the data sets. They are completely different data sets. So for example, the person data frame, which has 3 columns, you see in here, and 5 rows. Alright, it has the identity, personal, family. When you go to the site data frame, it has how many lines? Has 3. And how many columns? Name, latitude, longitude, completely different. And then you have the survey, alright, and again it has multiple records, and it has 1, 2, 3, 4 columns. Alright. And we look at the visited, it has like 3 columns and like 8 records. Now, if we need to merge, yes. Oh. Thank you. So let me repeat, I mean, you should have told me before, I mean, I was talking to myself. So in here, we have loaded 4 data, we have loaded 4 data sets. We created like 4 data frames: person, site, survey, visited. You want to take a look at them, the data in here. They are completely different. So you have the person has a shape, is a data frame. The site has a different shape. And the survey has a different shape, right? And the visited have different shape, alright? Of course, there is common columns. So for example, visited has, for example, ident, and this one has ident, alright? So the question is how we merge these together. A complete different data frame, the number of records are different, and the columns are different. Yes, they are intersecting, could be intersecting in one of the columns. How we combine them, how we can combine them. So I'm sure if you do concatenate, you know that will be big and a lot of empty spot. And we have to decide about the join. So join, inner, outer, left, or right. Right? We have to decide about all of this. Right. So for that we have a function called merge, I think. Alright, so we printed them in here. That's the printing. So if I take a look at the visited and I display all the 3 records, okay, I save them in the visited subset, 3 records. So I could have 1-to-1 merge. So basically what I say, site. So site is the left. Site is the left. Usually when you merge in database, what you merge? Left table with right table. Alright, so site now is the left. Left table merge with visited subset. And left on, so name. So that's the column which is common in the left one. So name will be where? In the site. And right on site. So site is a column where? In the visited. Huh? In the visited. Let's take a look at the visited and the site. Let's go back in here. Alright, where is visited? Site, in here. So, visited, yeah, and visit and site. Okay, and this is site. So what is the common common column between these two data frames? Take a look at site in here and visitors. What is a common column? So you have in here the ident, the site, and the date. Alright? And in here, so this is the name, which is DR1, DR3, and MSK. And then in here again, this is the site, this is the common one in here, right? So remember in database when you need to join two tables, everybody taken database before, right? No?
No.
No? Okay. Who did not take databases? Come on. Right? So at least this information when you need, okay, database built of what? Tables, right? 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 So I could explain it to you.
I've seen this before though. The
Huh?
I've seen the inner join. And
Yeah, yeah, sure. So for example, quick thing about database. Alright. Let's say that we have student ID, last name, first name, okay, and we have in here, this is a student address, for example. Or just call it to grade. Grades. Okay, grades table. So we have grade 1, grade 2, grade 3, grade 4, right? Right? So this is what we have in here, student ID. So instead of putting everything in one table to be used to create a table for the students and the table for the grades. All right. So now if I need to join these tables, how can I join them?
Student ID.
By a key, by a key, right? What is a common key in here? This. So what we call this in here, primary key. And this in here, what we call it? Foreign key, right? Foreign key. So now I could join them, right? That's what is join. Taking the information from two tables. How can I join them? With the key, with a common key. So if I have, for example, 3, 4, 5, 6, 7, for example, apples, Shakur, for example, okay, in here, and the grades in here, this is in here 3, 4, 5, 6, 7, okay, grades for 99, 85, 71, 61, the grades, right? So if I need to get, if I need to get the grades of this person, all right, what I have to do? I have to join the two tables in what? On the student ID. On the student ID, right? Same thing in here. What is the common between the two tables? It is the site, all right? So I have to join them using that key, the common thing. Otherwise I cannot join them. Otherwise I cannot join them, right? So that's exactly what we did in here. Take a look in here. So in here exactly what we did. So in here merge, okay, site.merge, visited subset. So these, the name, okay, it's in the site, the same thing as site on the visited. It's the same column. Then you join them, and then if I bring them in here, that's what I have in here. When you merge them, that's what will happen. So in here, this column's coming from where? From the two tables. They are merged together. How they are merged together? Using the same key. What is the key? The name, call the name in here, and the site. In the other two. Alright, simple database. Okay. Alright, so that's what is the merge. It could get very complex. It could be very complex. All right. You could have also, for example, this is like one-to-one. That means there's one element common in both tables. You could have one-to-many. All right, one-to-many. So in here, for example, many-to-one. So many-to-one, M2-1, merge, site with the visited, and when you merged it, as you see in here, let me call it out in here, that's what happened. Many-to-one. Okay, many, DR1, DR to 1. And also you could have many-to-many, many-to-many, as you see in here. Okay, so in here, in many-to-many, you have merged two tables, and it will give you a very big table like that. Okay, so you have to be very careful. By the way, I mean, maybe now it's very confusing. Maybe I'm not able to present it very well because like a lot of data, and you have to take a look closely about, when you do the merge, what the data happens. All right. All I'm trying here to tell you that when you do merge, okay, it could get very complex. Depends on the data you have. All right. So you have to look for at least one common columns between the two data frames you are merging. At least one. All right. And then that could create a lot of empty spots in your table. All right. If you have to merge, you have to merge. Most of the time, you have to merge. Okay. If the data is collected, so for example, if you're having a project to collect data, all right, huge data, right? And so let's say you have a group 1 supposed to select that much of the data, and a group 2 that much of data, and a group 3 that much of data, right? At the end of the month, you have to combine together to start your analysis process. Okay, so how you combine them, what you're gonna do with the missing data or created holes in your data, that's something you need to take up. I'm sure that when you go, you read it and you try it out, you will understand what I'm talking about, okay? The data is so big, and it's very hard to visualize it easily in the class environment. It has something, you have to run it and all of that. How long is the forward break? Alright, so once you do the merge, you'll create. There's a lot of missing data. Missing data. What's the reason for missing data? There's many reasons. The data could be collected missing. All right. When you join, the tables could create missing data also. All right. So how you deal with that? Before you start doing your analysis, you have to fix. So if there is, for example, if you are collecting, for example, like the age for 1 million record, okay, and some of the data is missing. So if you need to calculate the average, how you will calculate the average for missing data? You can't. You have to substitute it with something. So maybe you decide to substitute it with 0. You might substitute it with the average value, or substitute it with the with equal to the previous value or the next value after sorting. Okay, so you have to do something, right? We'll talk about handling missing data when we come from the break. Thank you.
regarding that assignment in last chapter, which we have to make print that kind of graph. So when I tried doing it, it was not printing in PyCharm. But when I tried using Jupyter notebook, so it printed giving an error, but in the end it printed. So do we need to have some code or file so that it gets printed in PyCharm?
Just to finish the class.
You have to
Yeah, I did everything, but I didn't get anything.
Send me a code, we can try it.
Sure.
I don't know if you can. Give the right. When you get that from somewhere. Does it have a full set? Oh, no? Oh.
Deal with missing data. Right. So the first thing is how a Panda represents missing data. Missing data is not a zero, it's not a zero string, it's not a value, it's a different value called nan, and it could be written as like this, nan, or nan, small, or capitals. Alright? And it comes from NumPy. So if you need to use it, you have to import the NumPy file. Okay? So let's go quickly over that. So there are many representations of the missing data. Okay, Panda represented as nan value. Alright. Fine. So make sure that if you need to use it, you have to import you could import it from NumPy. Alright, if you need to assign a nan to a value directly in the table, so first of all you have to do, you have to import it from NumPy. Alright, so again, it's not a zero string, it's a different value, it's a different value. Alright, so missing values are tested. So in here, for example, I'm not sure if you can see it, it's not clear. So print nan equals true, false. Print nan equals false is false. Nan equals zero is false. Nan equals empty string is false. So nan is none of the types. It's just a different type. Okay, it's not a boolean, it's not a number, it's not a float, it's not a digit, it's not a string, it's not of that. Alright, so checking against other missing values. So nan, does nan equal nan, false, nan equals nan, false, nan. So anyways, so nan is a representation for the empty data in your data, right? There is there's two methods to check for nan in your data, which is null, the first one, and not null. Alright, I'm very sorry if it's not clear, very much clear, Okay, so for example, if I say, for example, PD is for Panda, it's like a function from Panda, is null now, that's true. Okay, so how to check if the value equals nan with this function is null. Is null nan true, nan with capitals true. So there's three values representing the none or empty data. Alright. There is another function called not null. So this is null, not null. Alright. So 42 is it not null? Yes, true. Missing, true. Okay. And not null, false, because nan is a null. So null value. Anyways. So where does missing data come from? Why we have missing data? For 4 reasons. You could have 4 reasons to get a missing data. And I think you agree on that. The first one, when you load the data. So you have a file, comma separating file, it has missing data. So the data you collected, it's a missing data, right? Or you could get when you merge data. We just seen that in a few examples before, right? When you merge 2 files of data frames, you could generate an empty spots. Or when user input values is empty, or when you do reindexing. So all of these are reasons. Just take one or 2, and you could take a look at the other reasons. Okay. So when you read, for example, a CSV function, there are 3 parameters related to reading missing value. All right. The first one, NA_ values, and it's kind of confusing, but I'll try to help you to understand it. Okay. And the other one, keep default, and there's NA, and the last one is an A value. So basically, the first 2 that's what we usually use. So what are these values? Again, what we are talking about, there's a function called load_CVS, right? What is the first parameter you have in that function? The file.
name.
The file name. Is there other parameters? There's 3 more. Okay, there's 3 more. And 3 more to deal with what? With empty data. Right? With missing data. Alright? So basically, when you say load at CSV, right? What is the first parameter you have in here? A file, right? .csv, right? Right? Now, there's other parameters usually, right? 3 of them are to deal with missing data. So if there is missing data in the file, how you deal with it? Okay? Clear? Okay, what are these values? The first one is the NA. The first one is NA_values. Alright. So the parameter allows you to specify additional missing or NaN values. Alright, so what does it mean by additional? So if there is a missing data, okay, by default it will be NaN, right? Alright, but there is sometimes, like in the health data collection, there is some numbers means missing data. So for example, in the health industry, when you collect data and there is no value, you substitute it with 90. So 90, that means what? No data. Alright, as an example. So by default, NaN is no data. But what if I need to consider things, other values as no data? So where I specify that? In this value. Yes.
Could you give a range in that spot?
No, it has to be a list. It will be a list, so you could have different values.
Okay, so it can't be like any value greater than this value?
I don't think so. It has to be specific in the list.
Okay.
So you pass for that value. So when you say this in a value, it equals to a list. So for example, 90.
Okay.
It has to be a list, inside the list. Alright? Maybe we'll see example in a second. So you can pass in either a Python string or list-like. So it could be a string or list-like object to be automatically coded as missing values when the file is read. So whatever you put there in that list, what you are telling the load, that if you find these values in your table, then consider it as missing data. Simple. Okay? Simple. Okay. Of course, default missing values such as NA or NaN or NaN, there's another N in here, NaN, are already available, which is why this parameter is not always used. I wouldn't have to include it, it's already there. You need to add to it. Alright? Some health data may code 99. So in the health sim industry, 99 as a missing value to specify the use of this value, you should, okay, what you should, and here my friend, and here what you have to see in here, in A underscore values, 99. If there is another value, so you can add another value on all of that. So you could pass it as a string or as a value, all right? So now that's the first one. Mostly that's the only variable in the load you're gonna use. Okay, mostly. All right. The other one, which is keep default in A. All right. So usually by default it's what? True. That means consider the list and the NaNs. Okay. If you make it false, it will not consider the NaNs as empty values. All right. Confusing, right?
How will it consider it? How will it treat it?
It will treat it as, it will remove it from the data, it will load empty. It will not put none. We'll see example. Alright. Myself, I'm not convinced that's the right way to do it, but that's how it works. Okay? Alright, so it's again, so basically let's go back. So you're missing data, what they could be part of the data already now. That's the default will be considered as missing data. Or you could decide, for example, certain values, consider them as missing, like 99, for example. Whenever you see 99, consider it missing. So you could control that. Right at the time you are uploading the data to a data frame. All right. So let's read in here. The keep default in A parameter is Boolean. That allows you to specify whether an additional values need to be considered as missing. Alright? So what we are trying to say, that you could add different values for missing data, but you have to make this true as well. It's like a switch to make it true. Alright. The parameter is true by default, meaning any additional missing value specified with the NA values parameter will be appended to the list. Alright. However, keep default underscore n can also be set to false. It could be false. Alright. The third one is useless. So I'm not doing. I feel it's like useless. So you have to let's take examples. The first thing is examples. So take a look in here. In here we are loading the data from survey visited CVS. Alright. Alright. And by default, when you load it, it will load what? Let's take a look. What is this? Let's take a look in here, honey. Take a look live, okay? So in here we're loading the survey visited. We're loading it where? We're loading it in. In here. We're loading. Okay, we're loading it and printing it directly. Okay. So did we specify any parameters in here out of the three? No. So by default, what is the missing data? Is the NaN. And the NaN. All right. So let's we'll see the printout for that. Okay. So by default, the NaN is the only missing parameter. Okay. The only missing parameter. Okay. Now we need to load it with keep default in A false. So look what happened. Okay, what happened? The default NaN, it was not loaded as NaN, loaded empty spot. So when I made it false, it told the load, whenever you see NaN in your data, just remove it. Alright? Now when I load keep the default NaN true, okay, it was kept in here. It was kept, alright? By default it's true, by default, okay? In here what I did, okay, the NA values is empty and in here is false, okay? So it it's loaded okay, because it's empty in here, it only considered the NaN. But you know, if I make it, okay, this should be true, by the way, should be true. And here when you make it false, it will remove it, alright? Same thing in here. Let me take a look in here. So in here, loading the data, keep false. In here, true. Okay, in here, empty. Okay, in here, what I did. Look in here, what I did. All right. So in here, take a look at this in here. So in here, I said that any value 619, consider it what? As missing value. Alright? As missing value. Alright? And that's what it is. So this is 619, right? It's substituted with now. Look at the original, it was 619. When I said any value 619, consider it as missing, it was substituted what? With now. Alright? And because I said keep default NaN false, remove this in here. When I made it false, it only considers whatever inside that value as missing value. When I made it true in here, look in here, so what I said in here, any value 619, consider it as missing. And if you have NaN, consider it as missing also. So that's what happened in this one in here. You take a look. The 619 converted to what? To missing. And whatever was missing continued to be missing. The only way you comprehend it is just to play with it. Just please play with it like what I did. Okay, you'll understand what it is. Alright. So what we are doing in here, okay, what we are saying, there is so many reasons for having missing data. The first reason is when you load the file. Okay, how can you control this? There's 3 parameters, you're gonna pass them out of the file. This will control how your pandas will consider missing values. Simple, all right? Play with the parameters, try and understand how they work together. That's what you need to do, okay? All right. Okay. Now, the second reason for having the missing data is merge. We saw that from previous chapter. Okay, so we have in here, for example, 2 data sets, right? And when we merge them together, it has created like empty spots. All right. So you have to deal with it somehow. All right. And here, for example, okay, we will do the merge. Okay, there is we merged 2 data frames. We created some missing data. So how are you gonna deal with it? How are you gonna deal with it? Okay, the other thing is user input. I mean, sometimes you create like a series or a frame by your coding. For example, in here, as you see in here, you created a series. So GOT for whatever this is equals NaN. So you create it as an empty. You could always, in here, for example, you created what? A data frame. Scientist data frame. So the name, there's 2 names. Occupation, there's 2 names. Born, there's 2 names. Died, 2 names. Missing, two are missing are nans. So you created that. So you could, as a programmer, create some data frames where there's missing data. So that's the third reason. So the first reason, by loading the data. Number two, by merging data frames. Number three, by creation. You have created that, which is like, okay. And by reindexing. So for example, looking here at this data. So in here, I'm sorry if you can't see it, just watch your book. And here, what you are trying, this data from the first lecture maybe. So in here, like you are grouping by year, and you're calculating the average life expectancy. Okay, right? We went over this data set. So this is countries, data about countries. One of the columns is the life expectancy, right? So I'm grouping by what? By the year. Then I'm calculating what? The life expectancy. So in here, for example, the life expectancy for 2007 is 67 years, whatever. For all the countries, that's the average per year, right? All right. But as you know, the data, the data is, it's not for every year. So you have 1992, 1997, 2002, right? What if you try to reindex? You're saying I need the range of from 2000 to 2010. For 2000, there's no value. It's not in the data set. So it will create and will give you what? Now. For 2001, now. 2002 is already there, gave you the number. And so when you do reindexing, right? Okay, like it will create empty data spots or missing data, right? All right, so there's different reasons for having missing data. So you have to deal with it, how you deal with it, right? So how you work with the missing data, So in here, for example, that's example for loading time series CSV, all right? So from the Ebola, we already covered, we went over this Ebola. Then count. So I need to know how many, Ebola per countries. So how many for date, how many records? 2022 full, there's no missing. Day full. Cases, Guyana 93, that means there is missing. That's a maximum 2022, and so on and so forth. So you'll see there's a lot of data missing in that big data. So that's the first thing you want to do. I mean, when you have a data set, when you receive a data set, you need to work on. You need to know how much or how many data are missing. Column, and the whole data. And few tools will help you to do that. All right. In here, for example, the missing data, working with the missing data, so you subscribe the total number of rows and with the count. So how many missing for the date? 0. How many missing for the day? 0. How many missing for this one? 110. So now we know how many elements are missing. Alright? So missing values for data frame, you could know the missing values for the data frame, and it's like 1214 missing for the data frame. For this column alone, there's 29 are missing. There's 29 elements. So it's a very easy to know how many elements are missing. The question is, what you do if there is an element is missing? What you do? All right. Before you start doing your data analysis or calculations or all of that, what you have to do? You have to think what you have to do with the data. So what are the options you have? Okay, the first option is recode or replace. So you could say any missing data, replace it with 0. Or any missing data, replace it with 100. Okay, right? Number 2 is fill forward. So any missing data, look at the number before it and give it to it. So let's say that I have the number before is 5 and the next one is 10 and it's missing. Which number I have to give it? 5. Fill forward. And the other way is fill backward. So look at the next one, what is the value, and give it the same value. And then you have interpolate that you need to have the same space. So let's say, for example, is like, the previous number is 2, the next number 4. So you need to have the same space both sides. So it has to be what? 3. We'll see example in a second. And then the last one, drop the missing values. So if there is a line, a series that has missing values, just drop it as a whole. Okay? Yes?
When you have a massive data set and you have a significant percentage of data that's missing, what kind of effects does fill forward and fill backward actually have
I
on the
don't
data?
know. I really don't know. That depends on the data. So let me show you an example. Depends on the data. That's your decision, right? So, example, this is, which one is this? This is fill a data. So in here there's a missing values. So what we did in here, we said that Ebola fill NA was 0. Okay, so whenever I have a missing value, just fill it with what? With zeros. Remove the NA and fill it with 0. That's your decision. I mean, does it make sense? Does not make sense? That depends on what? And the data and what you are trying to do. Alright? Okay. So a fill in A is like many other pandas functions, has a parameter for any place. So it will do it in a place right away for you. Okay? So this is, for example, that's your question, is fill for word, right? This is fill for word. Alright. So this was missing, right? So it looks at the one before it and fill. Does it make sense? That depends on the data set you're doing, right? Alright? So in here, for example, in here, it could not substitute anything. Why? Because there is nothing before it to cover, so it stays. So you have to find another solution for this. About this was missing. So 79977, it fell forward. Took it in here, same thing, fell forward. You look in here, it's like this is fell backward. Okay, fell backward. So it has to look for the next one. The next one is nothing. Nothing. That could not do anything. Same thing in here. Okay, maybe other places where, for example, let's say it's missing. So this 49, it will fill it for maybe this here. So in here, this was missing. So it will look at the next one and fill it up. So fell backward and fell forward. Okay. Again, how much it makes sense for your data? Okay, that's your data. What are you trying to do, right? Okay. This will make sense, by the way, if the data is sorted, for example. Sorted, so in here is interpolate. What is interpolate? It's like equal space between the before and the after. Alright, so look in here, this was missing in here. Okay, so you add this to this, divide by 2 will give you this. In here, because nothing in back, you cannot do interpolate. In here, the same thing, add this to this, divided by 2 will give you this. So it has to be equally spaced before and after. Alright? Then the last thing is to drop. A drop. So we can use the drop in A method to drop missing data and specify parameters to this method that control the data dropped. So the how parameter lets you specify whether a row or a column is dropped, okay, when any or all of the data is missing. So you could make a decision that, I have a row that there is missing values. Whenever you have a missing value, drop it. Drop the whole row. Does not make any sense. Okay? Or if it's all missing, like all the records are missing, why you need it? It's clear, right? But the problem is, I mean, sometimes like you have a row that has like 100 values, 100 readings, and you're missing 2 or 3. Does it make sense to drop it? Well, that's your call. That's your data analysis. All right. This here we're teaching you tool. How to do your data analysis depends on the data that you have to do. Okay. It could work in a threshold parameter. Let's you specify how many non-nan values you have before dropping the row or the column. So you could drop the row and you could drop the column. Alright? If you don't like all of these remedies, like the 4 remedies, create your own. Right? You could create your own because you loop through your data and create your own. If there is a missing, do something. Okay, you have your magic, you know what to do. Okay? So these are tools ready for you to use. Alright? Let's say they don't satisfy your function of what you're trying to do. You could program your own. You have the data frame, and you could go through the data frame cell by cell, or column by column, or row by row. Right? You could do whatever you wanna do. Anyways, you got the idea. So, okay, where is the problem? And the question is, where is the problem keeping the missing values? So, for example, take example there. Okay, we are adding here. So here, if you take a look in here, what we are trying to do, we are trying to create a column by adding 3 columns. Try to create a column by adding 3 columns. But the problem, if one of the columns have missing data, and how can you add it? So what will be the result? NaN. Alright? So some functions you cannot do multiplication, you cannot do you can multiply anything with NaN or add NaN to anything. So you have to okay, so it could work with some average functions and all of them. So in here, for example, look in here. So I'm trying to add the 3, and so because I have one NaN, give me NaN. Same thing in here. Here worked fine. But in here problem. Here is a problem. So that's why we have to clean the data. We have to know what to do with the data in the advance. Alright, clear so far? So what we have learned so far in the first section of this lecture, that usually we give the data in multiple files. So we have to merge them, we have concatenate them together, whether around x0 or x1, alright? If they are identical, the job is very easy, no problems, no troubles. But mostly, or most of the cases, or some of the cases, I don't know most of the cases, some of the cases, that the data files, they are completely different. They intersect in 1 column or 2 columns. So what I have to do? Merge. I have to do merge. When I do merge, like any database, you have to do joint, right? Joint. So there's left joint, right joint, outer joint, inner joint. Okay, you have to really understand all of these tricks. All right. So we have to do that, but we have also to realize that quite often that when we do the join, what we generate a data frame with missing values. So we're going to come to the second section today, how we deal with missing values. So missing, there's many reasons. The merge, it could be from the data collected, it could be from the data frames I created in my program, it could be from re-indexing. There's multiple reasons to have missing data. So before I start doing anything, alright, think about like you using your data, like for example, if you are using machine learning. Anybody worked in machine learning before? Deep learning? No? Deep learning? Machine learning? Okay? So what you do? I mean, tell them what you do. Where do you start from?
I mean, aside from sorting out the data, deciding if it's sort of numerical or word-based, you can assign values to the word-based ones to help it make it easier.
So you start from dataset. Dataset usually huge, like maybe thousands of lines, and what we call the lines records, and what we call the columns features, right? That's what we call them, features, right? So before you start training we call training, okay, machine learning to training, just you have to normalize the data sometimes. So you have to take a look, make sure deal with the empty data, okay? Sometimes you need to do normalization. So what is example for normalization?
Standard scaling.
Okay, give them example.
It's sort of like evening out the values, I would say.
Exactly, it's like converting that range of data to a smaller range. So for example, let's say that the reading is like diabetes reading, right? So the person is considered diabetic when what's the number? It should be above 120. I don't know it's in unit. Okay, so you know they take a blood, all right. So I mean, if it's like 120 and up over, you are diabetic. Less, you are not, right? So let's say that these people, these patients, we have read the numbers, 80, 70, 100, 200, 350, okay. Do I care about these numbers? Do I care about this? What I care about? Diabetic or not diabetic? So what I have to do with this data? Normalize it. What does normalizing mean? Convert it to 0 and 1. If 1, then diabetic. 0, not diabetic. If the number is 133, what I'll give it? 1. If the number is 88, what I'll give it? 0. This normalization, right? So you have to normalize the data. Then after that, you do training and all of it. This is a different story. So the first step for data, for artificial intelligence, machine learning, data learning, all right, okay. Or before that, you don't have to go deep learning, machine learning, all of that. Data, like data analysis, right? You need to graph the statistics, do all of these. You have to fix your data, right? So these tools, very important. So what you're gonna do? I mean, even if you are not doing anything else, okay, you have like CSV file, comma separated file, right? And you need to fix the data there, okay? You have one option to load it to Excel, okay, and you have like 1,000 by 1,000. Go figure how to fix it, right? Can you do it? I don't think so. You cannot do it. So that's one day, right? Well, the best thing is what you do. This CSV file, what you do? You load it to where? To data frame, and you fix it. Do normalization, removing of missing data, do whatever you want. Right? And then what you do at the end? Save it back to CSV file, but fixed. Right? So Panda, even if you don't want to go, or go R or Python or Pandas, even if you don't want to go to machine learning, deep learning, just for data analysis, for business analysis, right? Data fixing it's very useful. Okay, load it to your Panda, do your magic, all the tools you have, okay? Or if you need to do graphics or whatever, anything you want to do, charts, anything, and save it back to fix to where? To your CSV, all right? So it's like a tool. Tool is very useful tool. If you know how to use it, it will be very, very useful to do. So that's what we call it TEDdy data. TEDdy data, okay? Data that all right. So basically for TEDdy data, you have to make sure that the columns are variables, okay, not values. Can you have in the column a value rather than a value? The column head? Yes, we could. So for example, in here, I hope I have time. What time is it?
12.
8, 12.
8, 12?
8:12?
Yeah.
Okay, I don't have time. Okay, that's fine. All right. So in here, for example, look at this data. Okay, in here. So I'll give you the idea, you finish it by yourself, all right? So this table, okay, how many columns they have? 5, right? So what is the first column? Religion. Okay, then income, I think, less than 10,000 K, between 10, okay. So is this a variable or a value? Value. That's not good. For many of, I mean, it's good for collecting the data, but this is not good. I mean, it should be variable. So we have to find a way to convert it to where? To a value. So what should be, it should be religion, it should be one column called what? Income, okay, and count. How many have that count, how that number, okay? So how we do that? Okay. So we have to, there is a function given to us called melt, all right? Where you melt these multiple columns, similar values actually, to 2, okay? As you see in here, okay? So in here what we do, okay? So you have U1, mel, W, the data set, ID bars religion. So this is are the only thing in a mail, everything will be melted. When you print it now, what you have, look what you have, the religion, variable, and the values. And the value. So the whole line of multiple columns, we converted into 2 columns, okay? And which is the variable, okay? So how many we have, for example, how many people who are agnostic, and the income is less than 10,000, 27 people, and that's what we call melting, right? All right. So if I bring the tail, for example, in here, this is the head, the tail, this is the tail. So again, the religion, for example, go to the last one, and affiliated, no, whatever. So unaffiliated, and they have the value is 597 record. Okay, so that's what is melted. So TD data is to convert the data to, all the columns have to be variables, not values. So in here, for example, I could give it a name. So what I did in here, so melt, and the ID variables, I'm gonna keep the religion. The variable name is income, and the value name is count. Alright? When I print it, now I have religion, 1 column, income, and the count. So I took many columns and I converted them to 2 columns. So what will happen to my data? Will be smaller or bigger? Same size. But instead of it's like spread like this, it will go split down. It will spread down, right? But definitely now for data analysis, that will be much more easier. It's the TD data. It's the TD data. So the rest of the chapter tools, we take a look at it, those examples in there, but you got the idea now, okay? That, you know, keep multiple, okay, in the first example, we kept 1 column fixed, which is religion, right? Some cases that you need to keep multiple columns fixed, okay? And I'll show you this example quickly. I will not add it to my PowerPoint slide. So for example, this is example in here. keep multiple columns fixed. So we have the data set about the billboard, right? When you read it, so what are the columns? The year, the artist, the track, time, date entered, and then the ratings for so many weeks. There's a rate for so many, so week 1, week 2, week 3. So it's like you have so many columns. Week 1 rating, week 2. So this is wrong. This is not a teddy. So these I have to convert this so many columns. I have to convert them to how many columns? 2 columns. Okay, 2 columns. And that's another example like having that. Alright. So then it talks about like columns containing multiple variables and all of that. Okay. Anyways, so it's okay. You could take a look at the examples in the book. So that's the third thing. Third thing we learned today is the table or the data frame has to be tidy. What does it mean tidy? Means all the columns need to be variables, not values. All right. If there is a values, I have to convert all of these values to two columns, value and name of the value, whatever, right? Okay, all right, and that's what we call it, melt. Sometimes also it's the other. We need to pivot. We pivot. So we have like, for example, remember in the Ebola example, so what did we have? Country. I think we have the country. Forgot what the country, for example, Nigeria, what is Nigeria? Cases, and there is Nigeria, for example, deaths. Okay, deaths. Alright. So we have a columns like this, right? Alright. So sometimes I need to convert these to 2 columns. And that's what we call it. Pivot. Melt and pivot. Alright? The tools are available. Okay, I think using the tools are not so difficult. Okay, more than planning for it. Okay? From now you should understand what is the most difficult part of dealing with data file. What do you think?
Don't know.
You don't know. What do you think?
Just filtering out bad data.
Sure. But what is the first thing? What is the most difficult part? So let's say all the tools, you have them, you are fluent with them, you know how to use them. Excellent. Okay? All of that. What is the first step that you have to do?
Identify what you're solving for or what you're looking for in particular.
Understanding the data set you're working with. So you have to understand the data set, alright? Because not all the time you are given a clean, tidy data set. So sometimes you need, forget about looking for missing data, that's a different issue. We're talking about in here about how the data is neat. Sometimes you need to melt columns, melt them, bring them where down, and sometimes what you need to do, pivot, bring more columns. Alright? That really needs your deep understanding for the data in hand. That's number one, and what you plan to do with it. So this data is good if it's represented as columns, or better if it's represented as a record. Alright, pivot and melt. Right? So I think today is a lot of things that you need to try in your dish. So you need to try them all. Try to play with the. Believe me, the best thing is to go and. Luckily, you have the data sets. I already sent you the data sets, the zip file. You have them. You don't have to worry looking for them. all you have to do is just to look at the code written in the book, write it by yourself, play with it, see. I mean, the book will show you one example to how to deal with it. But believe me, how many other options you have? Many. So the more you do it, the more you try things in your own and try to build the data in a different way. I mean, you'll be able to have like a good grip how to handle the data in hand and what to do. All right. So today we have covered again, for belief, merging data together, data frames together, dealing with missing data, how to missing data happens and how you deal with it, how you fix it. Number 3, how to create TD data. TD data. That means melting and pivoting the data. Next week we'll move on. And as I told you, I have my lectures from last semester, so you don't have to wait for me. All right, so you could go and watch these. I'm sure there is like thousands of resources in YouTube and internet. So next week we're gonna talk about data types. Okay, data types. And right now, so far it's just we have the data in the tables. We did not deal with it. So data type could be what? Could be string. Could be text data. Okay, it could be like date. All right, and we're gonna learn about apply. So apply is a function, right? That you could apply it in every cell or every row, it's how to integrate functions with your pandas. And then we're gonna talk about group by operations, split, apply, combine, split, apply, combine, split, apply, combine. Okay, so split, then apply a function, then combine. Okay, this is also like a big thing to fixing the data. And then we will talk about date time and dates and all that in the data. Alright, so lots to cover. Okay, so just to let you know, how many lectures left, just to plan ourselves.
Chapter 3.
2 lectures, I think.